Okay, we're in section 18, and we're certainly moving along, all right? So we're in section 18. The whole section is designed for you to get you familiar with the problems that are going to be introduced in exercise 18. And the bottom line, there's contents like every other section of the notes. There's examples, which I go through in these videos, and there's exercises that you need to get busy doing, all right? So, again, I realize some people may want to reach out to me. My email address is Bannon, that's B as in boy, ANNON.US. These documents are being made available to the Prison Mathematics Project participants only. All right, in the future I will publish it, and certainly when that happens, I'll make it known, all right? I'll make it known on YouTube, and certainly I'll make it known for anyone who reaches out to me asking me how to get the document, all right? Let me kind of scroll through this document. You know, someone says, I wonder what section this section's about. Well, you're going to be reading through it, and, you know, typically what they're talking about, looking at it, looks like they're doing more factorizations, right? More factorizations. And someone says, a lot of work, all these factorizations. Mathematics is really involved greatly with factorizations. So the one thing I would recommend you do, looking at problems, there's things I'd look for, and the things I look for, you know, someone says, why is that? I guess experience. I'd look for GCF. I'd look for, like, grouping patterns. I'd look for quadratics. I'd look for patterns that I know about. All right. So the first thing I'd look for is what's called the greatest common factor between those two terms. So just looking at the number, I'd say 2 is common between those two terms. I would say a factor of A is common between those two terms. I would say a factor of X is common between those two terms. And I'd say a factor of Y squared. And this was known as the greatest common factor. What's left over? Well, let's take a look at it. I'm going to say X squared. That's what's left over for the first term. What's left over for the second term? Minus, well, 4, certainly. That's what's left over, because 2 times 4 is 8. I got the A, I got the X, and I got now, what do I have? I have Y squared. Now, you may think that's the end of it, and it may be the end of it, but now I'm seeing there's a quadratic there, and it's a difference of perfect squares, and I know how to factor that. It's a pattern problem. That's going to be X minus 2Y and X plus 2Y. And I'll put a little box on that, indicating there's not much else I can do. It's right over here. All right? Same answer. Right? We're not expecting any different. Let's look at the next one. And looking at it, you know, certainly if I'm looking at it, I would say this looks like a perfect cube problem to me. And I need to know those patterns. Let me write this down. So A squared cubed minus B square cubed. Let's write this down. What do you get? You would get A squared minus B squared times, well, I'm not going to square the A squared now, that's A4, plus A squared times B squared, well, that's just A squared B squared, and then it's going to be plus the B squared squared, which is B4. Now, again, a lot of students say they're done, and I'm not saying you're not done. Yeah, after you're done, you're done. But what I notice immediately, the first factor, A squared minus B squared, is factorable to A plus B, A minus B. All right? Now, I want to point out, if you're looking at the answer key, you do see that. All right, it's right over here. Now, I'm going to say, yeah, if I look at this thing, I'd probably say right now, I'm done. And I got to be honest with you, nowadays most students would say they're done, and most teachers would say they're done. But Wells takes an additional step. Right, so I'm going to say this is good. If you got there, whoops, sorry about that. Let me get my pen out again. If you got here, you did good. All right? But let me just remind you what Wells did in the past. All right, what Wells did in the past. Let me see if I did this right. You notice I noticed on my notes I did it differently. That's fine, though. All right? I'm still going to work on it. All right, so why would you work on it? I want to get there. And I know it's tough. Right? So I'm going to get the same answer that Wells got. Now, when I'm looking at the work, by the way, I notice that my work over here is different than what I'm doing over here. But I'm just going to write this down for you. I'm going to write down A4 plus, I'm doing this second guy. And this is something we've done in the past. I'm going to write down 2A squared B squared plus B4 minus A squared B squared. Again, I'm going to remind you what we're doing. We're just factoring this guy over here. And I understand stopping there. I do. Now, we did this in the past, though. All right, now why is that? Well, I got this now. This is A squared plus B squared squared minus A squared B squared. And this factors beautifully. And it's a difference of perfect squares. What's it factor to? A squared plus b squared minus ab times a squared plus b squared plus ab. All right, let me write that down for you now. We just factored. This is going to be a plus b, a minus b, and I just factored that thing I've highlighted in green, and it turns out to be a squared plus b squared minus ab. We'll check the key later. A squared plus b squared plus ab. Put a box on it. I want to check it. I'm checking with my answer over here. What do I see? The a minus b, a plus b. I got the first two factors. Then I see a squared. I know they put this in a different order. That's fine. I see that factor, and I see this factor. It worked out beautifully. Again, nowadays, and I hate to say this, a lot of students would stop here. They wouldn't go forward. And we'd be happy if they got there, by the way. We really would. Again, what I did in the notes, I didn't do the difference of perfect cubes. What I did first was I did the squares. All right? Did that first. You get the same answer no matter what road you take. All right, let's take this one over here. And, I'm looking at it, and I'm wondering, what pattern could that be? And there's many ways to do this, including long division, but I'm kind of looking for something that might be easier for me to deal with. So I'm going to say this looks like a difference of perfect squares. Let me write that down for you. And you're going to get much better. I'm sorry, I made a mistake already. That's why, isn't it? And I can do it. And when you get over there, you would get x4 minus y4 times x4 plus y4. All right? And I'm looking at the x4 minus y4, and that's also a difference of perfect squares. And again, I'm getting a little better at this. I'm going to say this is x squared minus y squared times x squared plus y squared. And then there's x4 plus y4. What do you get over here? Let's keep going. It's going to be a difference of perfect squares, x minus y, x plus y, times x squared plus y squared, and then x4 plus y4. Again, we're going to just outline that for you and make sure you understand that we're looking at this over here. Do I get what I expected to get? Exactly the same thing. Boom, boom, boom. Everything's good. All right, let's keep going. And again, I'm looking at this thing over here, and my gut feeling about this one over here, you might say, I don't know what to do. What I would suggest you do is just start factoring, and I'll put this down for you. We'll look at the key later. And this is 2, and then I see m plus n. That's a difference of perfect squares, by the way, m minus n. Now, what do I notice immediately now? I notice there's a factor common to those two terms. I'm going to pull it out. And what do you get? M plus n times, I'm going to use square brackets now, 3 minus 2 m minus n. Let me clean it up. This is m plus n times, well, let's take a look at this. You get 3 minus 2m plus 2n. Let's take a look, see how we did. And what I mean by that, look at the key. And I think I made a mistake somewhere. And where did I make that mistake? I gotta look. I hate to say it, I'm looking. Oh, I see it. I copied wrong. I got it. And I really mean that. I'm so glad I have an answer key because I copied incorrectly. And I'll go back over that with you. And again, I apologize for copying incorrectly. And I'll go back over that. And again, I'm saying it. I'm looking at the K. And let me tell you what I copied incorrectly. This is 2 here. All right, let's go again. Again, I don't look at the answer. I'm going to do it again. So what am I going to factor out? I'm going to factor out m plus n. So I'm going to use a square bracket over here. And that's going to be 3. Well, I took out one factor of m plus n, so one factor remains. And this will be minus 2 m minus n square bracket. Okay, let me go through the work. This is m plus n. And I'm going to do what's inside now. That's 3m plus 3n minus 2m plus 2n. Let me keep going. M plus n. 3m minus 2m is 1m. And 3n plus 2n is 5n. I'm going to say that's my answer. Let's look at the key. Now, you have made a mistake, I look again. I got it. M plus n, m plus 5n. Looks great. Let's look at the next one. Next one, again, looking at it, you might say, oh, you can't do it. There's nothing common between those. So what I would claim to do is just multiply it out and see what happens. What do you get? A squared. This is not factoring, by the way. I'm just multiplying it out. Minus a minus b squared plus b. So what I'm going to do is I'm going to rearrange the terms. A squared minus b squared. You may wonder why that is. I'm looking at a squared and b squared to kind of belong together. And last but not least, you got minus a plus b. I'm going to factor by grouping. And what's that mean? I'm going to take the first two terms and the last two terms and just factor them. The first two terms factor to a minus b times a plus b. And the last two terms, a minus 1 pulls out, and you're left off with a minus b. What do I notice now? And I'll point it out to you. These two terms have a common factor, and the common factor having in common is a minus b. Let me put that down for you. Whoops, sorry about that. My eraser out. A minus b pulls out. And what are you left off with? Well, from the first term, you're left off with a plus b. And for the second term, you're left off with minus 1. I'll put a box in that. Then again, like before, if I make a mistake, I'll fess up to it. But let's look at the k. I see the a minus b. I see the a plus b minus 1. I'm feeling good about it, all right? So what do? You need to reinforce it. What do you mean by reinforcing? Do the exercises. Whoops, I keep doing that, don't I? Do the exercises, all right? Why do you do exercise? To get stronger. And you're going to do a bunch of problems, and they're relatively simple problems. But again, I'm not saying you're at that stage yet. You'll get there. Answers are given to you, and some work, all right? Problem answers are given to you, and they may look really tough. The problem for a lot of students, though, they look at the problem, and they say, yeah, I can do that. You don't say, no, you can do that until you try. And the way you're going to try is you're going to do the work without looking at my work. After you're done with your work, what you should be doing is looking at the answer. If you're not getting the proper answer, try again. You may have to look at the work at some point, though. But looking at work is probably not going to be helpful unless you've done work initially. So you get through the problems, and again, I know it's a lot of work, and it's worthwhile work, by the way. It's really worthwhile work if you're moving forward in a STEM-related career. It's worthwhile. And what do you get? You eventually get to the end of the problem set. Oh, it's really long. And someone says, I can't do it all in one sitting. We'll take a couple sittings to do it, all right? Now, I'm the kind of person that really kind of trucks through things, and I want to get them over with. What I mean by that, I want to understand the material that's being presented. And the more time and effort that I spend on it, my God, look how many problems are here. I'm up to 52 problems already. That's a lot of problems, all right? So it's a lot of practice, no doubt about it. What we'd like you to do, we'd also like you to look at the SAGE code. What is that? That's a computer algebra system, also called CAS. It's free. It's used around the world. It is really a great system. All right, that's the URL that brings you to the saved website. On a saved website, you can either download the application or use the interactive web-based application. And we recommend you do these little code snippets, all right? See what happens. The code snippets are related to the material that we're covering in these notes, all right? So if you need to reach out to me, again, I know I say this a lot to you, but, depending where you are, you may not remember what's been said to you. That's fine. You can reach out to me by email. That's my email address. Again, my name is Ron Bannon. The email address is B as in boy, the @NNON.US. Okay? So, that's it. I hope to see you come back and continue forward until we get to 139. Thank you.